For those who were not with us the past three events, please join me in welcoming our speaker for today. He is an industrial designer and solutions architect at Accelerating Makers. He is a huge fan of using traditional and digital methods to turn ideas into real products. He believes that great ideas can come from anywhere, and digital fabrication technologies make it possible for anyone to design and create. Ladies and gentlemen, please welcome back Sir Gideon Catalan.
Hi, everyone. Thank you for the introduction and thank you for having me here in this webinar. So good to see everyone here. And I think this will be the last of our series where I'll be here. And so I hope you have enjoyed our learning so far. I keep forgetting the cameras up here. And that I hope you guys learn a lot today. So we'll be learning a lot about smart cities. We'll be learning about new technologies. And in some way, our past discussions are kind of going to culminate in this one because we've talked about theoretical developments, we've talked about discrete developments like specific parts, but now we're going to look at smart cities, which exist as an entire combination and sort of all the technologies coming together in a single concept. So it's a very exciting way, and I think it's the perfect way for us to end and cap off these series of talks. So before I continue, first is that throughout the presentation, if you have any questions or would like me to clarify something, or if you have some learnings that you'd like to share, feel free to send them in the chat box. I try to check it every now and then, and you're more than welcome to leave questions and any comments there so I can see. If there are any issues with the stream, for example, if my audio cuts out or if it turns out I'm not presenting, you can raise a hand or let me know. No problem at all. If you have any questions during the webinar, we will be having a Q&A portion at the end. So you can save your questions or you can leave them in the chat box and we'll address them by the end of the webinar. And finally, around midway through, we'll be having a 10-minute break. So there will be opportunity for us to refresh ourselves and maybe go to the bathroom if needed. Okay, so let me share my screen now so we can get started. All right. So I believe, okay, I see a thumbs up, which I assume means that we're good. Okay, so welcome. And thank you for joining me here today for a webinar on Industry 4.0, Smart Cities and Emerging Technologies. So my name is Gideon Catalan, and I'm a solutions architect as well as an industrial designer. And as part of Accelerating Makers, our goal is to introduce and talk about these technologies and these concepts around the Philippines. And so it's a great opportunity for me to be invited to these social innovation talks, and I hope that we all learn a lot today. Now, for a webinar today, what we're going to learn today is first, we're going to do a recap. Since this is the final event from the past 3 webinars, it would be fair to kind of look back and see where we are now with our information. Next, we're going to look at emerging technologies. So this is a very general term, but we're going to try to survey the landscape to see what are some specific technologies that have come about in Industry 4.0. Then we're going to have a short break, then move on to part 2. And in part 2, we're going to first talk about smart cities. So smart cities and how they work and what makes up a smart city. And then we'll transition to smart citizens because we are people living in the Industry 4.0 and living in these smart technologies. So what does it mean for us as someone who's living in this time and experiencing and using this technology? And then at the end, we'll have a Q&A portion for us to address any questions that you may have. All right. Now, the goal of our webinar today is first, we want to understand what does smart mean? We throw it a lot in our products, in smart cities, smartphones. What does smart really mean? Then we want to talk about a smart city. How do we imagine an entire city as a smart being? Okay. We're going to look at some of the challenges, some of the difficulties that are faced when you're talking about smart technologies. Then finally, we want to know the benefits. How does smart cities affect us as citizens, and how does it affect populations, countries, even entire nations? Okay. Now, to recap, the first topic that we discussed was about Industry 4.0. So as the name implies, Industry 4.0 is the current period that we live in today. And it came about from a series of previous industrial revolutions. First one was about steam power and using mechanization. Then the next revolution was when they introduced mass production, assembly line, as well as electricity. And then the industry was changed again with the introduction of computers and the concept of automation and electronics. And now, as we've discussed previously, we live currently in Industry 4.0, which is a new age of cyber physical systems, Internet of Things, as well as very powerful networks. So in this Industry 4.0, it's very important that we establish that we are living in it first, and that this is a industry that's driven by technology. Industry 4.0 uses a lot of terms, but some of them we can distill as we have transparency, we have interconnectivity, we have decentralized systems, as well as assistance or systems that assist human beings in the day-to-day lives. And it's important to see that Industry 4.0 as a concept uses these ideas. And when we apply them to the concept of smart cities, when we apply them to the concepts of robots and artificial intelligence, you'll see just why these concepts have thrived and developed so much within Industry 4.0, because they are very closely related. Included here is also the concept of smart cities. As you can imagine, when Industry 3.0 happened, or when people had mechanization, steam power computers, cities changed drastically. So in the same way, with Industry 4.0, cities are also changing. And it's funny because when you're living within a period of change, at times it's very subtle and it's hard to see. So our goal right now is to look and consciously examine that change so that we can look at our surroundings, at our lifestyle, at the environment with a new perspective, a perspective of appreciation and understanding of Industry 4.0 and what it means for us. Part of our discussion also in the previous webinar was about digital fabrication. So this is the idea of fabricating or making things using computers or digital technology. So we talked about a lot of different machines, laser cutters, 3D printers, specific machines. But we wanted to more of discuss the concept, which is that using computers, using digitalization allows us to make things, manufacturing, hobbies, prototyping, handiwork, even schoolwork, to make things better, meaning more efficient, safer, also to make things easier and more accessible. And that's easy to understand when you go to the concept of, if you know how to use a computer, you can actually use digital fabrication. And that concept of accessibility and ease of use is what makes digital fabrication so powerful. Okay? So linking into digital fabrication was the concept of the Fab Lab or the makerspace. So this concept is a space that promotes innovation, meaning similar to a laboratory where you have tools, you have machines, as well as a place where you learn. A Fab Lab is designed to allow people to create things, to fabricate, which is the fab, and then laboratory because it's a learning environment. And the gist of this is that because digital technology is so accessible, and because innovation is very important to human development, whether it's through product development or social development, Fab Labs came about as a goal to promote development and innovation using digital fabrication technology. And Fab Labs as a concept, they are here in the Philippines. They're a network of laboratories all over the world, some of which are here in the Philippines, in many schools all over. So it's not a alien concept that you have to go abroad to find. Even here in the Philippines, there are many Fab Labs, even since 2016, that are working hard to promote innovation as well as collaboration using digital fabrication. So it's a good way to set the mood and also, I guess, to recap of what we've done before, because we've talked a lot about more of conceptual ideas. Fab Labs as a concept, Industry 4.0 as a concept also. So the goal of our discussion today, this one is more concrete. We want to look at what are some discrete examples of this technology. We want to take concept ideas like robots, which for many might be overwhelming or mysterious, and we want to break them down into more easy to understand terms. And by the end of this, I'm not expecting that we'll be able to build our own robot, but will be able to appreciate just how amazing technology in your phone, just how amazing the technology in a light bulb is because of the technological developments in Industry 4.0. So it's a great way to get perspective and to understand these machines. Now, when we talk about emerging technologies, there are quite a few that we're going to go through. So we have some concepts such as robotics, artificial intelligence. We'll also discuss the importance of 5G or networks and other items here. And our goal here isn't necessarily to become experts about each individual topic, but the goal is for us to get an understanding and an overview and ultimately appreciation of these new technologies. So to begin our webinar, the first one we want to discuss is robotics and AI. And this is a pretty cool concept. And if you were to read it, it's really something that would kind of blow your mind. Like, okay, robots and AI, that's something very futuristic, very science fiction almost. But robotics and AI are actually already here around us. And while we may say, oh, okay, fine, that's technically AI, like, Google Assistant or Cortana or Siri. I want to break it down and I want to go deeper into what it means to use these artificial intelligence. And these don't apply just to those typical assistance app, even certain apps that we use every day, such as Spotify, for example, the way it recommends your music, the way it knows what kind of tracks to listen to, how it recommends and picks which one you are likely to listen to. For example, social media, how it determines what kind of content you want to see. Have you ever clicked on an ad and then suddenly for the next 3 days you get nothing but ads for motorcycle parts? So those are all examples of AI actually in action. And when we see them happening, we take it for granted. We go shopping and we see ads that are recommended to us and we think, yeah, I kind of have an idea. They have an ad profile and it works. But all of these examples, they're very subtle. And they're very hidden ways for us as consumers. But they are very good examples of how artificial intelligence is permeating all of our technology. All right. And we're talking about apps. So these are mostly software, things that we use on a phone. But we always bring up the idea that they're also smart, right? We always say, okay, on my smartphone, I have a smart app. But the goal is that have you ever wondered what exactly does smart mean? We can label a smartphone. We can label a smart TV. We can even have I think they have smart light bulbs that automatically turn off or monitor their electricity usage. So we slap on the word smart a lot. And so let's put a proper definition to it. At the same time, our main topic of smart cities needs to properly background what exactly makes it smart. So smart, in this webinar, we'll be presenting it as an acronym for Self-Monitoring, Analysis and Reporting Technology. So let's break it down to each word. Self-monitoring. The idea is that smart technologies are self-monitoring, meaning they are aware or they can sense or they can perceive in some way their environment, their state, or their surroundings. Case in point, let's go with a cell phone. A smartphone is self-monitoring because it knows its battery, how much life it has. It knows its signal level. It can tell you if the light is on. It can tell you if the music is playing. It can tell you even its location. It can even tell you if it has a gyroscope, for example, if the phone is tilted left or right. They have light sensors that can tell you if you're using it outdoors or indoors. Self-monitoring means that technology is able to sense or see or is aware of its surroundings. And that's very important. So that's the S and the M. For the A is analysis. So there are many machines that can do this. For example, a piece of paper will be able to monitor if it's hot, if it's set on fire. But what makes smart technology smart is because they also do analysis. Not only does your cell phone know how much voltage is in its battery, it analyzes that voltage, compares it with the expected values, and can give you a percentage on how much power it has left. It will even analyze that power and give itself a rate of decay and can tell you for how many hours your cell phone will last. More so, it will even take the data of your how much memory or how much power it draws during operation, and it will compare it and say, if you use your phone actively, you will only have 5 hours of battery left. So that kind of analysis, the ability to not just grab data, not just to be aware, but to actually analyze the data it's getting and make conclusions with it. Cell phone might be easy. Let's go for um, a light bulb. So I'm sure you've seen smart street lamps, right? Those that turn automatically on and off. So one example that they're analyzing is that they can detect, of course, how bright it is to determine what time of day. But one thing they can also do is even store electricity. They can determine that if there's a lot of electricity, they can store the rest. And at night, when there's no solar power, they can use it to power themselves. Another form of analysis. So the next one is reporting. Now, reporting is key because if a computer has all this information, but humans can't use it, then it wouldn't really count as smart because it doesn't matter to us, right? If I told you I had a smartphone, but the screen was blank and it was off, you wouldn't know it's smart because you can't use it or you can't read the data. So when a computer or a machine reports the information, that makes the data, that makes the analysis usable by humans, usable for other things. And that reporting is actually very subtle, but is a good distinction on the complexity of the machine. Reporting doesn't simply mean showing it on a screen. So on a cell phone, it's easy. You read it on a screen, that counts as reporting. But in other concepts, for example, smart plugs. Can I get a thumbs up if anyone here has ever had a smart plug, a smart light, or like a home assistant? I know they're quite popular. There, I see a couple. So, and you'll know that you can have like a dashboard. Like you open a website and it shows you a dashboard and tells you your home has been consuming this many kilowatts of electricity. This particular light bulb has been on for 4 hours and is consuming this much. This idea of reporting isn't it can be as basic as telling you the information, but it can even go to the level of a network. Imagine your entire home reporting everything, telling you how much electricity your air conditioning uses, when is the efficient time for, let's say Meralco has like lower cost hours, when is the water flowing, how much electricity did you leave a charger plugged in, for example. And this idea of reporting all this information is part of what makes it smart, because it allows humans to use and leverage that information. Finally, the T. And it's kind of ironic that the technology part is the simplest. Technology, it is something that is electronic and usable. So when we apply this concept of smart, right, you take this basic parts that it can monitor itself, it can analyze data, and it reports it either to you or to some server or network. Now you see the background of why we call other things smart. So you'll understand now why you would call a smart TV. You might see the perception of why it's called a smart car. Or if you saw a smart watering can, you'd have a slight idea of what it means. So the idea is that many different things, many different technologies are now becoming smart because we're applying these concepts. And let's take a step back. Self-monitoring, analysis, and reporting. Can anyone guess what that is very similar to in a previous webinar? It would be very similar to the principles of Industry 4.0, transparency, interconnectivity, and assistance. So you see here that smart technology and Industry 4.0 are very closely related because conceptually, they are simply the application of Industry 4.0. So that smartphone you're holding in your hand, these computers, these smart watches, smart gadgets, that's an example of Industry 4.0 in action that you're using it today. Okay, so it's important for me to get a background because I'll be throwing a lot of smart words here. I'll be throwing smartphone, smart home. So we at least have a established definition for smart. Now, the other thing that we want to look at in terms of emerging technologies is also robotics. So I'm sure we've seen videos of like Spot, the robot, and other robots from Boston Dynamics. And these are amazing machines, right? You see them and you're like, whoa, that's real. It's not CGI, it's not fake or programmed. They're actual real things. And while they seem pretty amazing, one of the things we're going to do is actually discuss robotics a bit in detail and kind of break it down. Because we'll realize that the same things that make this robot dog able to walk and open doors is, in some conceptual level, similar to the same way your phone knows whether to dim the screen if it's nighttime. It's the same technology that tells your camera to change the focus if something is blurry. When you boil down the concept of these robots and these technologies, the technologies that we interact with every day, from our simple cell phone to a simple watch, exercise the same smart capabilities as these machines. It just isn't as apparent. So that's what you want to appreciate. And when you introduce concepts even like deep learning and machine learning, which is forms of artificial intelligence, um, it seems so scary when you say deep learning and machine learning. Your mind goes crazy with like robots, like having their own sentience or like rebelling against humans. But do you remember the apps I showed you before? There's simple apps that will recommend what music you want, what your next suggested video on your playlist is. They use similar technologies. So what I'm trying to do here is taking these big and oftentimes intimidating concepts of robotics and AI and showing you that they are actually being applied to technologies that we use and we're familiar with every day. Okay? And finally, when you introduce something like the internet, the concept of these individual amazing technologies kind of multiplies. Because not only do you have a cell phone that is capable of doing so many things, you can now connect it to another machine that is capable of doing many other things. And that's kind of how it works. The internet is sort of like this accelerator, this catalyst that multiplies the power of these machines, of these technologies. And when you take, right, we talk about individual parts, like an individual cell phone, an individual car, but you combine it with a concept of the internet, this network, and you now generate this concept of big data. Okay, that's how I want to introduce this. Things like stock markets, things like dynamic systems, things like weather patterns, and even systems control. Things like data privacy, security systems on a website. All of those are examples of individual pieces of technology linking together through the internet, creating a complex network and system. And it's a cool way of breaking down and seeing just how complex some of the things we interact with every day are. And I hope it gives you an inspiration and appreciation, because not all of these technologies are perfect yet. When I was telling you about, robots taking over the world and getting their own sentience, it's not so far away, but it's certainly not there yet. So I don't think we have to worry. But when we think about these robots, these technologies, I want us to also break it down. Because, when you think of robots in like media or video games or movies, they're very complicated. But we can actually break down robotics in the same way and see how they apply. And we'll try to go this quite fast. And the goal is that we want to sort of appreciate robotics and see it as a way that Industry 4.0 expresses itself. And I'll explain that concept more as we go. So in robotics, there are many different kinds of robots. And one of the first ones is defined as human-robot interaction, because there are many robots that are in use today that are primarily for assistance. Manufacturing frequently makes use of these. And in human-robot interaction, these are robots that actually assist humans to do tasks. And these tasks usually are in the context of safety, because robots, for example, are much more robust and are not subject to the same limitations as humans. Robots are frequently used in dangerous situations, which assist humans because it's safer for robots to do certain tasks. So you've seen about robotic bomb disposal, and now they're introducing concepts such as firefighting or environmental rescue. They've used already robots for underwater exploration. And even in space, well, obviously it's dangerous for humans to go to space. We're using robots now to explore out there in different planets, different solar systems. And that's ways that robots are being used. Other functions is navigation. Robots that have the ability to see and perceive through sensors are now being used for things like autopilot, for example. Self-driving cars are another concepts that robots have been used in. So the final one is automation industry. And this is probably the most prevalent and immediate use of robotics today, because automation and manufacturing industry is a very big part and is a very automated process. And in fact, robotics is most used in this field, especially in terms of volume. So all these different robots may look different, they may operate different, they may have many forms, but when you break them down into their components, they all are kind of made of the same parts. So these four things: actuators, sensors, manipulators, and locomotion. So what we want to do is go through each of these individually. So actuation is the first. And actuation is simply as moving or actuating. Me moving my fingers is a form of actuation. And for a robot, it's actually a lot more difficult. You know, as humans, we have muscles, we have bones and tendons and ligaments. So motion is so simple for us. It's second nature. But for robots, it's much more difficult. And robots use actuation in many forms. So think of those complex robots I showed to you before, those ones that walk, the robots that dance, or that can move like an animal. And you can actually break each of them down to individual parts. Like the first one is motors. So they're simply moving and rotating. Other ways are for linear actuators, which are examples of sliding parts that move. There are series elastic actuators. So the idea here is that rather than it being a rigid forward and back, a elastic actuator actually can bounce a bit. So it's more similar to how humans move. Robot control. So this is the example of putting together these actuators. And the actuators themselves have different forms. For example, they've invented air muscles. So they use compressed air or pneumatics to contract and expand certain parts to create the illusion or simulate the movement of muscle. They've also done the same with wires. When you put an electric current through them, the wires will actually move and flex. And another one is electroactive polymers. So these ones are cool. I like this because it moves really funny. The way the polymers are dispersed inside the material means when you exert a current, they're actually flexed and moved according to the electric current. So pretty cool and weird. Even other concepts like piezoelectric motors. So it's a material that when you apply a current, it will actually move or contract or change in shape. And so when you combine multiple things, for example, in this example, 3 different piezo motors, 6 in total, are contracting and expanding in a certain pattern to slowly move a piece along a track. And we talked about all these movements, right? And we know that when humans move, muscles are just one part of the equation. You know, it's not enough that we can move our bones and our muscles around. But the other important part about movement or, functioning is robot sensors. And if you remember, I said before that your cell phone can actually perceive its environment when we talked about self-monitoring. The concept is also similar. So in this application, human senses have a robot equivalent. So for example, for humans, we have different senses: sight, smell, touch, hearing. Included is taste, but I don't think there are many robots yet that are exhibiting taste. So these senses are what we have. And we perceive based off of these senses. That's how we are monitoring the world. So that's our self-monitoring mechanism. But for robots, they require something different. In order for robots to understand and importantly perceive their environments, they require what we call sensors. And many of these sensors have a equivalent in human scale. So that's a way to frame it. So these 3, light sensors, which can detect brightness, sound sensors, which detects vibrations, and temperature sensors, which is a difference in temperature between 2 parts, their equivalent would actually be similar to what we do. And in action, a light sensor, for example, would be used to control automatic lights. A sound sensor would be for voice recognition. And the temperature sensors, for example, are for your computer or your phone that controls its operation based on the temperature of the machine. Now, the next senses, for example, for touch, can be covered by these 3. So first is contact sensor. So it detects when something is touched or when it makes physical contact. Pressure detects not only contact, but how hard we're pressing down on the material. And then tilt sensors, similar to what our ears do, and I forget the name of the fluid, my biology escapes me. But it can detect actually if the object is tilting left and right. So applications, for example, is touchscreens. Pressure sensors also for touchscreens, maybe for drawing tablets, and even tilt sensors for functions like video games or on your phone to be able to rotate the screen. And then finally, we also have distance sensors. So we talked about human sight, right? And perceiving and looking at things. So one of the most basic ways that machines can replicate this sense is by using distance sensors. So these can be automatic dispensers, this can be self-driving cars, or even assistive devices that can actually detect and see things before they happen. So the first example is IR sensor. So it detects an IR beam by shooting it forward and detecting when it bounces back. And this delay in the reflection actually determines the distance. Because if something is far away, the reflection will take longer to reach the sensor. Other one is a simple photo sensor. So I think if we've ever experimented with, have you ever received those greeting cards where when you open it, music will play or like something will move or turn on? And they usually use photo sensors. So when light hits the cell, it actually opens or changes the resistance of the circuit, meaning it can detect when light is hitting the object. So, it can detect that something's open or closed. Another one, and this is probably the cooler one in robotics, is ultrasonic sensors. So they look like eyeballs, and they actually do a similar function because they can actually see and measure distance. And how do they do that? One eyeball, or one of the circles, plays a ultrasonic sound from the speaker. And the other part listens to the reflection or the echo. And by determining the time between the sound and the echo, it can actually determine distance. And when you think of these things, they're quite simple, but you combine them with the ability to sense the environment. And now you have a concept of positioning, a concept of location. So a robot, normally it doesn't know where it is. Using these sensors can see to an extent, mimicking the human equivalent of eyes. And in application, these would be, for example, automated robots that can move around the factory. This can even be robots that follow a line. And when you go to a grand scale, self-driving vehicles use a similar concept in their daily operation. Now, another form of sense is also GPS, using satellite signals to determine its position within the world. Another is magnetic compasses. So these are usually used on your phones to determine its orientation relative to the Earth's magnetic field. And then gyroscopes. So similar to how humans are able to keep our balance, a gyroscope helps to maintain orientation when the robot is tilted. So frequently used in self-driving cars, self-balancing robots. LiDAR, another concept, similar to radar, but uses light, and the same concept, the reflection, to determine its surroundings. Okay, so these are examples of senses. And when I talk about technology that is self-monitoring, these are the usual methods we have. If you're talking about let's say a smart watch, it can detect, for example, your pulse or your heart rate using light and determining how red your blood is, feeling the beat of your pulse on your wrist. It can also detect motion by determining vibrations and steps. It can determine your route by using GPS. So when we talk about self-monitoring devices, these are usually the systems that are used. Okay. Now, end effect manipulators. Hands are kind of important. And end effect manipulators are effectively hands for a robot. They help manipulate or do things for the robot. And usually the form is either in mechanical grabbers or actuators. And the interesting part is, many times, the designs for many robots are actually inspired by those of nature. So inspired actually by, let's say, crabs for their claws, or even suctions using an octopus. And the equivalent would actually be these things. So whereas a crab would have a claw, a robot might have a mechanical gripper. And on the other hand, just like an octopus has suction cups, they have these suction end effectors also. So the example is that we're inspired by nature in its examples, and now we replicate those concepts using robots to be able to affect and move things. And so now you have a robot that can first move or actuate, sense using its sensors, and now do things or affect using its end effectors. So you see, we're building up the recipe for making a robot, right? Now, the very final one. When we combine those actuators, the ability to move parts, when we combine the ability to sense things like balance, positioning, motion, you can now start to explore advanced concepts like locomotion or moving or moving around. And the examples here are really cool because what I want us to do is look at these complex robots, right? They're made up of all these parts that we're not sure. But when you break it down to, a sliding linear joint or a motor rotating this way, you'll start to understand that even beyond the complex programming, they're kind of made out of the same parts. The arm moves up and down, the leg moves up and down in a certain way. And that's how these robots function. So they've developed robots that can crawl using like multiple limbs. They've even developed robots that can hop, which is a very interesting and kind of amazing example. Robotic kangaroos, even ones that do complex jumps like these. They've designed robots that roll, probably the most basic if you'd imagine. But certainly these robots don't look basic. There are even robots that employ slithering. So the concept of using the manipulation of the entire body to gain traction where it's necessary to move on a surface. And they've actually explored slithering a lot in dangerous environments. For example, during earthquakes or during debris, a slithering robot would be most effective at navigating that environment. They even have robots that swim. So for example, here, these are simple actuators that move, or those which are the soft polymers that can flex or contract, combine the motion and mimic some natural movements to actually have robots that can swim and move on their own. And so when you think about these robots, they seem complex, but we can actually break them down to individual, motion parts, and as a way of understanding how the robots apply. So next one are types of robots. So very quickly, there are many different kinds of robots, especially when we talk about automation and manufacturing. So articulated, which is kind of similar to a arm. You've also got SCARA. So these use arms that move on a pivot. Also stands for selective compliance articulated robot. So the idea there is by changing the angles of each arm, you can achieve a wide range of motion. Other example is Delta. So deltas are cool because they seem like this, complex thing, and they move this effector in a really cool way. So it's a very amazing way of using mathematics and motion to create these movements. And then finally, Cartesian. So this probably is the one we're most similar with. Maybe 3D printers or desktop printers will actually use this kind of motion. And it simply means moving in an XY plane, like a Cartesian plane. And when you combine these motion systems together, you can create robots that move in amazing ways, with wheels, with legs, even the concept of something called swarm bots, that robots that move together as a system to create objects like these. You can create robots that fly or robots that swim, such as drones. And now, when you go to future of robotics and AI, we know that the technology is quickly improving. The limitations, which is the hardware, are quickly being overcome thanks to new inventions. And we're creating robots that can actually assist human beings with day-to-day tasks. And on the other hand, not just in enhancing abilities, but even for assistive tasks, such as using motion control. For example, robots that can replicate and assist movement, even motion systems that can use brainwaves for motion. So simply as exerting brain activity can allow you to do certain things. They've even developed robots that can navigate using hand gestures. So imagine being able to control a car or a phone simply using gestures rather than using a steering wheel. So different ways. And another application is also in healthcare. So you here have robots that are actually trying to improve the way that people perform surgery or healthcare in order to make operations safer or more convenient. or maybe complex certain tasks. So one example of this is they're actually exploring healthcare because of COVID-19. Because there are infected patients, robots, which can't get infected or can transmit the disease, can actually perform these operations instead. So different forms. And the cool ones, like soft robotics. So there are a lot of concepts for it. And I kind of like looking at the slide because they're so weird to look at. But it just gives you ideas on what's possible with this technology. And I mean, every day we find new and new examples of what people are doing. Drones that are being used to assist agriculture, for example, that they've done in Iligan. Many different applications of these robots. And one that we don't often deal with is cobots. So cobots or cooperative robots are frequently used in robotics or manufacturing. So for example, imagine you had to arrange 1,000 bottles every hour into a crate. Rather than doing it by hand, you can have a robot assist you and perform that task. So cobots, which are designed to assist humans in functions. Now, one of the things that we'll transition to is also IoT. So the reason we want to move here, coming from robots, is because robots, they represent sort of like the hardware side, physical side of doing things. And IoT, which means Internet of Things, represents also a way of those senses. So we talked about your phone is in some way a robot because your phone has properties or components that are similar to a robot. It can sense things, and at times it can even actuate, like vibrate. But when you combine concepts with IoT, for example, so in IoT, the idea is that you have these individual technologies that have information, and these are called things. And what happens is using the Internet of Things, it connects these technologies together and leverages it into a network. That's what Internet of Things is. And these things can be anything from your cell phone, a light bulb, a adapter, even all the way to a speaker, or even your refrigerator. All of these counts as things within an IoT system, as long as it can communicate and transmit data. And in an IoT network, this is important to establish because we preface this for smart cities because IoT forms the backbone. In an IoT system, your car tells you how much gas it has. Your electricity meters will tell you how much heat you're consuming. Your fridge will tell you how much food is left inside. Your computer will tell you how long it's been on. Your coffee maker will make you coffee at this time. All of these different things, these machines, form up this mini network of objects. And this network is what people use to assist their lives. For example, an IoT system that assists me right now would be being able to monitor the weather. A wind vane with a data sensor module tells me how windy it is. Temperature sensors will tell me the temperature in different parts of the city. A camera that can determine clouds or cloud patterns in the sky will tell me the forecast for the patterns. And when you put those things together in a single network, you create the ability to predict weather. You create the ability to monitor what's the weather going to be for the next 5 days. And that assists us with our day-to-day task. I know it's going to rain or I know it won't. I know when to plan outings and I know when I should stay home. So these kinds of things assist us by using this network of data. And this is important because the IoT concept will apply not just to small scales, such as a house, but the concept of an IoT can apply even to a city, where those things can become cars. It could become cell phones. It could become a bus. It can become a industrial waste plant. When you combine those things in an IoT network and scale it up, you create the concept of a smart city. So it's important for us to preface this. And all the individual technologies I talked about before, robots, actuators, those sensors, it's important for us to establish those because when we think of a smart city, which is looking at the big picture, we know that individual parts, those individual things that make up a smart city are those things. Your street lamps, which have light sensors, a car, which has a positioning sensor and can monitor its gas output, even the roads, which have cameras, which can determine how many cars are on the road. Maybe it's a pollution sensor that detects particles in the air to give you the air pollution index. all of those things, those individual sensors, individual actuators, individual robots, so to speak, make up this network. And that's what creates this smart city. And when we talk about that network, right, we're always talking about data being moved to and from. We're talking about data from your cell phone to a server, data from your car. And that's why it's important to also discuss 5G, which is a form of wireless transmission. Okay, so 5G, it has a long history as it's why it's five, and there's one, two, three, four, five also. It generally means how much data you can transport wirelessly. So 5G is a relatively recent innovation that allows us to transmit more amounts of data wirelessly, which means you can transmit more data faster or more data securely and consistently. And what this does is 5G forms the backbone of the network. Because imagine having a million different sensors in a city, but you can only read 10 of them at a time. Obviously, then the technology won't work. But because we have 5G, which functions as a very powerful high volume data transmission system, you can actually read and pull or take data from hundreds of thousands of different things all at once. And that ability to read that data, that ability to send information wirelessly and almost instantaneously is what makes IoT work. It's what drives, at its core, Industry 4.0. So 5G is very important and essential as the backbone for the networking concept in smart cities. Now, so here, so you can go from 1G all the way to 5G. But the gist is really just that bigger data transmissions. And that's why when we talk about us, like at home, you have your Wi-Fi network. It's of course difficult. I think someone mentioned that they wish they had faster internet to make their work better, but it's the same concept. If your Wi-Fi in your home can only handle 2 cell phones and 1 computer, then it's limiting your data. It's limiting how much information you can process. You can't have 2 people talking to their friends online, another person presenting a webinar, another person going to class, another person playing video games. But when you have a higher data transmission, faster Wi-Fi, or maybe a LAN cable to allow better data transmission, you can do more things at the same time. And the same concept applies to smart cities. 5G, which is a high volume transmission of wireless data, allows us to get information from more places, from more things faster. Okay. Now, there are other concepts here on this, what you call it again? Technology that's coming up, such as blockchain. And we won't go too deep into detail on these concepts, but it's important to realize that blockchain is another result that's very closely related to Industry 4.0. I'm sure many people here are familiar with blockchain, whether it's the concept of cryptocurrencies or any of those kinds of things. Blockchain, part of it, also relies on a similar concept of being able to connect to different systems and networks in a decentralized system. That's why it's very key as an emerging technology in Industry 4.0. So remember we mentioned some principles of Industry 4.0 are decentralization, interconnectivity, as well as transparency. Those 3 are actually very, for those who are familiar with blockchain, it's very, it's part of the core structure of how blockchain operates. Because in the same concept, blockchains rely on interconnected networks of systems that do computing power, that do verification through transparency by checking hashes or the unique code and the unique history of that chain. And this concept of transparency, because you can see the entire value of a blockchain or the entire history of this thing, this piece of code or this piece of data, it's part of what drives how it works. And without it, blockchain wouldn't be able to operate. So essentially, blockchain is very much a result of Industry 4.0. So blockchain, which also evolves the concept of cryptocurrencies, NFTs, trading, and even like online purchases that use these concepts, again, they all link to that same concept, that they are driven primarily by the principles of Industry 4.0. Even concepts like VR, virtual reality. This time banks more on assistive technologies, the ability to enhance or assist human beings in perceiving things. In this case, if you remember, one of the things I mentioned in Industry 4.0 was cyber physical systems. VR, or virtual reality, actually represents a way for us to transcend that boundary and explore that cyber physical space and system in real time. So sometimes it may look ridiculous, people doing crazy things, but there are actually some very amazing and practical ways that people are using this technology when it comes to healthcare, when it comes to education, even when it comes to sciences and arts. And the key part here is that these technologies are coming about, and honestly, there's still many things that are developing. Has anyone here ever played VR chat or any video game that involves a concept of a digital space in virtual reality? So I haven't yet done it myself, but there's this entire society, community that has this sort of virtual gathering system. And I want to mention this specifically because when I say that Industry 4.0 is a revolution that's happening today, there are new things that are coming about. And just like many new concepts that are very novel, there are also some emerging patterns, emerging behaviors in those communities. It's interesting and it's also worth looking at just how cyber physical systems interact, especially when you combine the concept of VR, which blurs the line between digital and physical systems, and see what emergent behaviors, emergent communities, and patterns come about. So it's just emerging technologies are very, very important to keep an eye on. Another one is green technology. So we covered this previously, but the concept is that it seems almost antithetical because we talk a lot about the effects of pollution, which are largely due to human factors, and technology is one of those causes. But using this technology can actually allow us to address that problem and create new solutions, interesting ways. And when we mention smart, right, one of the concepts that are applying for smart technology is a factory. So the idea is a factory that is actually monitoring its own output, its own waste production, and can selectively and strategically address pollution concerns on a data-driven level. And that's where smart technology is being used. So the next one, quantum computing. The gist here is that it may seem like science fiction at the moment, but very, very powerful computers are being developed. And in turn, they're allowing us to produce much more complex calculations, operations, and they're transforming how much power we have in a digital sense. So I won't go into detail here because it's a very complex concept for quantum computing. But the idea is that just as, for example, steam power, right? Steam power transformed how human physical power was. We no longer had to rely on human physical power or animal power. We can use steam or mechanical energy. In the same way, quantum computing can represent a revolution where we're no longer limited to human brain power, but we may be able to harness powerful artificial computing technologies. And the implications of that, I have no idea. People with PhDs would have ideas. But the idea here is that complex and powerful computing systems are being developed that will transform the way we think and the way that we process data and information. So, and it's kind of perfect because you have Industry 4.0, which has metric tons of data, so much information. And now using these technologies, we have the computing power to process and understand that data. So they go perfectly hand in hand. And it's no accident that it's flourishing in Industry 4.0. Okay, so I know that this is a lot. And that's kind of how emerging technologies functions. We have Industry 4.0, which we interact with a lot, but we also need to realize that there are much more advanced technological applications happening. And what we use on a day-to-day basis, our smartphones, the technologies that we interact with, they are a small example and application of these concepts, but there is so much more that they can be developed into. And that's why one of the questions that was asked to me before is what can we see in the future of Industry 4.0? It's hard. It's impossible to predict because as you can see here, just these examples of new technologies are already dramatically changing how society operates today. The internet has changed. Blockchain has changed how we perceive currency and value. 5G is transforming the way we communicate. And even quantum computing and virtual reality, they're shattering our perception of the limitations of what is physical, what is digital, and the limitations of what computing can do. And when we consider all of these technologies, we see that the future of Industry 4.0 really is uncertain. And it's sort of like the Wild West. Anything can happen. And it's kind of cool seeing, the emerging technologies that happen in it. And okay, so now that we've discussed a lot of these new technologies and emerging technologies, we will next go towards smart cities. And the reason I wanted to take special emphasis on this is because when we look at smart cities, they are the culmination of all of these technological advancements. They represent the technology on an individual basis being scaled up to the size of the city. And as individuals, as citizens, or even as people who want to be shakers and movers in society, it's important for us to realize what makes the basis or what makes the ingredients pretty much of these smart cities and these technological revolutions, just to appreciate and fully see the complexity and how intense really the technology is. So let's put a break and let our brains sort of cool down. I know it's quite a lot. And when we resume on this break, we're going to discuss now smart cities. And we're going to look at all of these amazing technologies and how they're applying on a city scale. And at the same time, we also want to look at the human-centric approach because we've been talking so much about technology. Let's see a few examples of where human-centric applications of Industry 4.0 can happen. All right? Okay, welcome back. I hope everyone's okay. I hope we had a good time to calm down and bring our brains back. Okay, so now to continue the discussion, and this one I want us, this one will be less technical in this sense. So we've talked about smart technologies, right? And there's different ones. You've got smartphones, homes, printers, smart cars. But now we want to take that concept of smart and we want to scale it up. And when you scale up individual objects, you get stuff like home AIs or smart homes. So as some have responded before, some people actually use this here in this webinar. They have homes that tell you their electric consumption. They can turn off lights. They can change the temperature of their air conditioning, turn on a fan, blinds, some cool stuff. They can play music wherever they want. So that's what it is. When you scale up the idea of smart technology, the first one is a smart home. Everything about the home that you control. You can also control not just through like an app, but you can control it through gestures. We've seen clap lights. You can have like blinds that you can program to open at a certain time of day. You have security systems like cameras that detect whether doors are opened, whether there's motion outside your house. You even have, for eco-friendly purposes, electrical consumption, waste production. It can track how much heat is being lost through your air conditioning. And you can scale it also to other technologies like smart cars, which have the ability to drive their own, the ability to navigate. You have smartphones, or, it's a device that now has become almost universal. So the idea that you can buy food, you can message friends, you can take pictures, you can play video games, you can earn money, you can edit a video, you can transfer files, you can do almost anything on a cell phone using these technologies. And when you take those individual parts, you take those smart homes, smart cars, smartphones, and you combine them into an entire city, that's what you get in the concept of a smart city. So in a smart city, the idea is we take these individual smart things and we combine them into a entire scale. So in a smart city, things, for example, like security, there are monitors that monitor streets, that monitor activity in high population areas. There's alert systems, for example, earthquakes, natural calamities, disaster, or if there are fires. There is an automated way that lets users of the city know that there's a fire or there's an earthquake. Smart cars, for example. In some cities, they have transportation that will actually automatically notify when they're going to be in the station. So imagine you want to go, you commute using the MRT. You can check your phone and know exactly when it's arriving. You can know how full the MRT will be when you get there. You can know how long it takes at each station, and you can give you an idea. There are cities now that are mobile centric. I think almost everywhere in the city, you have access to signal, which means either for mobile data or for calling, and it promotes that usage. And if you notice, Wi-Fi is becoming more and more of a public infrastructure, and there are movements that are trying to make it into a need and a necessity. Again, like I mentioned, public transit. There are functions now such as beep cards, which are RFIDs or in some way a smart currency way of paying for for transportation. Even smart automations. Sometimes they use automated lights in other countries that can actually control the flow of traffic depending on which lane needs it more. So the idea is you take the concept of smart, you take those individual parts of a smart object, that it's self-monitoring, that it analyzes data, that it reports the data, and you transform it not just to discrete objects, but into an entire city, an entire system. And that creates this new idea. And to be fair, smart cities are a difficult concept because not only are we dealing with new technology, we're dealing with infrastructure. We're dealing with things that have high level of inertia and a lot of bureaucracy to get through. But there are cities, for example, that are actually using smart cities. And the key example that we want to explore first is Singapore. Other examples they have are in New York, even in Barcelona. And if you notice that these are some key examples of how smart cities are functioning. So the first one we'll look at is New York. In New York, congestion management has actually been in place. Their stoplights no longer operate on a predetermined cycle, but their stoplights actually are based off of an analysis of traffic. Meaning, when the traffic system is aware of certain patterns of when traffic builds up, such as congestion, the city's automated stoplights will automatically flow and redirect traffic based on that information. Meaning, if there is light congestion in a certain area, the traffic lights will automatically accommodate that. And if they expect rush hour at a certain period, the streets will automatically have ways to accommodate that flow. And the results is, for example, Midtown Avenues can improve travel time by 10%, which may not seem like a lot, but when you scale it on a city scale, that's hundreds and thousands of dollars of gas, of time, of efficiency, and of the usage of vehicles that's improved thanks to this kind of system. Included there is also their Wi-Fi. So the idea is the concept of Link NYC. The goal was to provide free Wi-Fi phone calls and generally access to digital services throughout the city as part of the city services. So the goal of this was to promote these technologies and to increase the accessibility. Because one of the important parts about smart technologies, especially when you scale it to a city, is accessibility. Smart devices, they may seem like a thing because you have to have the phone. But the concept of smart cities also relies on the concept that everyone, a citizen of that city, has to be able to access the technology and use it. And it's part of what makes smart cities important. So by having these Link NYC, a program to link these services to people, they're able to further establish city services to assist citizens for what they need. So the next example is for Barcelona. So I like this example because first, it uses Fab Labs, and second, it has a human-centered solution, which I think will really appreciate living in the Philippines. So the first one is Fab Lab Barcelona was the first city to actually integrate Fab Labs as part of its project. So they would use Fab Labs and create this public network to actually link different Fab Labs into the city, which meant that Fab Labs no longer operated like an individual project, but they became part of the city's services. So they imagine like a concept where as a city services, it not only included public transportation or electricity, but now would include things like manufacturing, things like education for digital manufacturing. Those kinds of systems were adopted by Barcelona into an actual public network. Okay, next concept, and this is what I like as an example of a human-centric application of the technology, is a concept of super blocks. So as part of their city structure and city planning, they have these blocks of how the city is structured. But they actually evolved it and they found ways that rather than keeping a centering this, this kind of technology and this city planning around just cars and vehicles, they determined that in a superblocks model, they wanted to create certain areas that were focused more on people-centric movement. So the idea was first that they integrated smart technologies. For example, street lighting that was made smart, that can operate and change based off of data. It can have network technologies, both for energy saving, for security, as well as for convenience. And they combined this concept to create these super blocks, which were pedestrian-only areas or places that limited vehicle travel. And the idea was using the data they gathered from traffic, from systems, from people's cell phones about their motion and the way they interacted. Superblocks proved that by creating an area which is accessible for pedestrians, it increased and promoted things like pedestrian traffic, noise level, pollution, as well as even business. And the idea here is that if you did not have smart technologies, you would not be able to know the complete impact of these projects. You wouldn't be able to assess how well this information would work because smart technology does that. At the same time, you're able to facilitate these concepts of super blocks because you can use smart technology to control and to provide the services to citizens in that area, both to prevent pollution, to prevent crime, and to increase productivity in those areas. And so it's a very nice example that even though we're looking at a very technologically driven place and we're looking at data, we're looking at sensors and Industry 4.0, when you reflect it back to a human-centered goal, which is service for citizens, it's a good example of the technology being human-centered, despite having a lot of technological background in it. Singapore, which is very common as an example, is because it actually is using smart technology and wants to adopt it as a smart nation. So Singapore is actually doing a state, as in it's part of their part of the country to develop this smart technologies, both through technology, through AI. They have specific programs and establishments that work on technology for AI and even maker spaces that focus solely on artificial intelligence. And the reason for this is because Singapore determined that with its kind of size, with its space, with the way that the city is structured, smart technologies is essential. And one of the examples they did was to pioneer what they called autonomous vehicles for public transportation. So they've test piloted these systems in specific areas where there are actually no drivers for the buses and public transport, but it's actually completely automated. So imagine that rather than having to have public transport that is a fight against or that works against people or that the government doesn't support properly, they actually have public transport that is part and controlled based off the data needed, meaning it's not just driven by profit margins or by business practices, but it's actually driven by needs based off of smart technology. For example, where you need to be picked up, what locations are good, what kind of traffic is in the area. And these kinds of technologies are great examples of where they're adopting smart technology for more specific uses in a city in a larger scale. And now, when we talk about smart cities, it's also important that we want to try centering it here. Because for smart cities, they have a lot of implications in terms of how they can be used. The technology is scaled up, but it has different limitations. And specifically, when we're talking about citizens. So the idea of a smart city is that the four base concepts of Industry 4.0, right, has to apply to smart cities also. So for example, transparency. In a smart city, transparency is in the form of being able to see information, traffic levels, pollution, noise pollution, how much pedestrian traffic there is. Maybe in the case of, in the Philippines, congestion in terms of public transport. Maybe it can be in terms of the cost of goods or services. A driving force in smart technology is to be able to transparently see data. Next is interconnectivity. So the idea is people should be able to access this, because if the network or the services are only accessible to a certain group, to a certain let's say certain economic bracket, for example, then the concept of interconnectivity fails, because interconnectivity relies on being able to connect all users within a system. And that includes everyone in the masses, which means for if it were to be applied, for example, to the Philippines, you have to look at technology that doesn't only work for those who can afford it. Part of smart cities and how it operates is it needs to be accessible and make an interconnected network for everyone, not just select groups or select areas that can afford it, but everyone. That's why it's an important part. Next is for decentralization. So the goal of this is because you're dealing with information that's more data-driven, that's digital, there's no longer the reliance on individual areas or hubs of things. So the concept of, for example, like a town hall, city hall. Imagine that instead of having to go to a specific place or a branch to get your driver's license updated, your NBI clearance, and when you go there, there's hundreds of other people who have to line up and wait physically there. Imagine a place where you can apply for these things online in the convenience of the home, and you simply have to put in an application and wait, and you can do other things in the meantime. So those small concepts, small things that can be transformed using technology will have a profound effect. And this idea also applies in smart cities. When you digitize city services, it also means taking certain services and employing those fact that you don't anymore need to rely on a physical system, but you can rely on a cyber physical space, such as online services. And decentralizing these operations from instead of being a physical area to now being online is a big part of how it works. And the final one, which is assistance, because these technologies drive on the ability to assist people with things, whether it makes it easier to commute, whether it makes it safer and healthier to live in the city, whether it makes it cheaper for you to buy goods or gases or services in the country. Those are what smart technologies aim to do. And so these technologies have to be able to assist people. And it means that developing ways and services that benefit the citizens in the way that they need. So it's important to preface this when we're talking about in the Philippines, because when we talk about the examples here, you'll notice that they are very either conceptual or they're not yet fully developed. Um, so in this case, we're going to look at three specific examples of smart city applications, or at least certain applications of these. First one, for example, is a concept of a BGC app, which was something that they wanted to conceptualize. And so the idea was to turn a city, which in the case of BGC is already very technologically advanced, and combine it with an app. And imagine the ability to see traffic real time, to see parking where you want, to see which stores are open, to see if there's construction on this road or not. The idea is to be able to access and understand and see an entire city using a single program or application and understand and access the services. So in the case of the BGC app, it was very simple. Originally, it was only slated to be a parking guide, which seems very small, but it's a example of a small application of Industry 4.0 that kind of gives an idea of where we can apply it. Next one, for example, is in Taguig, which is the robo-nurse, which is kind of a funny application. But the idea was they wanted to try using robotics in the case of for pandemic, which was for the isolation of facilities. So the success of it is questionable, and whether it truly is robotics or not is still a thing, but the concept is still there. The idea is trying to use these technologies, especially in the context of those who need it, in the pandemic, for example. Last one, and this one is probably the most interesting, and I think the most feasible or credible of the three, is for Santa Rosa, Laguna. So Laguna, or Santa Rosa, the area, is actually has a lot of industrial parks and industrial manufacturing zones. So one of the projects was to actually link together all of these projects, services, and industries that function there to create this network of what industries are available in the Philippines. And the idea here was to get a better idea and to provide information and monitoring to see the industrialization here in the Philippines, especially in the Laguna area. So while it's limited to a specific area with, in a way, a very specific scope, it's a good example of leveraging the technology to get data to make better informed decisions. In this case, to monitor manufacturing for DOST. So when we look at these examples, there's others that sort of don't apply here specifically. Congestion management. I'm sure someone here has used Waze or Google Maps sometime in their life, but it's another program that uses artificial intelligence to an extent to actually monitor congestion and recommends alternate routes, for examples. Another one is SafePass, or one of the numerous apps that have been released for contact tracing. So it's the idea of, again, changing something from relying on a physical system to utilizing a more convenient and easier digital system. And when we talk about all of these concepts, you can see clearly here that after having gone through a lot of the exciting new technologies of Industry 4.0, the examples here we have in the Philippines are very limited. They're very small in scope, and they're very limited in terms of technology. But the idea is still there in that these kinds of technologies are still being developed. And even in other countries, they're still in action. But it's important for us to look at these technologies with importance, because as the technology continues to evolve, they will, one way or another, be used. We saw it with the rise of e-commerce. We saw it with the rise of food delivery, which are small but very key examples of technology shattering and transforming the way things operate. We saw it with transportation. For example, taxis now being generally outmoded by other forms. These kinds of technologies will continue to evolve. And it's important for us to consider smart cities, because if we let these technologies develop without keeping in mind the possibility of a smart city, which aims to help users, help its citizens using technology by providing services, by providing structure, and by providing data and information, then we have to use this technology. And remember, because when we continue to develop and when new technologies and services come up, smart cities will begin to play a more and more important role, because these technologies will develop whether we want them to or not. And the importance is finding a responsible use of the technology and implementing it in a way that benefits here in the Philippines. So smart cities represent a culmination of all of these technologies. And in the same way as it's a culmination of many different technologies coming into play, it's also important for us as people who live in a digital age and as well as citizens of this country to be aware of the technology and see how much power they hold, and that how much the development of these technologies can have a profound effect on also the way the country shapes and uses the information. So I think I will close the presentation here with these smart cities. And I hope that we learned a lot, both from the past webinars and also from this discussion, as a way to kind of see smart cities in action. And I guess since it's going to be the last one, Accelerating Makers is the program I work with. And our goal is to reach out to schools, institutions, anyone really, who wants to learn more about digital innovation. And if you kind of want to know more about these technologies, sorry, I'm giving a plug. Hope the host don't mind. We have a Facebook page at Accelerating Makers, or you can also look, you can see us there, or you can check our YouTube channel. So I'm sure you may want to be curious, about the other technologies like laser cutters, 3D printers, or you want to know more at your own pace about new technologies and how they can be used. There's a lot of videos there that can show you and talk about these technologies. So I'd encourage you there. Okay, so with that, I close my presentation, and I hope your brains are all right. Okay.
Wow, Sir Gideon, ending his talks with a bang. Thank you so much, sir. It was such a great and interesting talk, and I'm sure everyone here enjoyed it. So guys, check out Accelerating Makers. So please allow us to present you our certificate of appreciation, Sir Gideon.
Benilde HIFI would like to present this certificate of appreciation to Gideon Catalan for sharing his knowledge and expertise at Social Innovation Talks, Emerging Tech and Smart Cities, given this day, November 17, 2021. signed by Nico Moreno, Benilde HIFI Director. Thank you, Sir Gideon.
Thank you
All
very
right.
much.
Now we would like to invite all of you to our open forum or Q&A. To ask your questions, you may click the raise hand option in Zoom, or feel free to open your camera and raise your hand to be called. The floor is now open to your questions. To start, we have one from Anonymous. Sir Gideon, the question is, what happens when citizens rely solely on computers or AI? Is it really foolproof? Is it really foolproof? Do you think this idea is really necessary when we already live in a world without them for more than a century?
Um, I'd say it's more of like assistive technology. So I guess it kind of goes the same way. You could say, well, we've lived hundreds of thousands of years without electricity. Would electricity be really necessary? So I know it's like a big, like sometimes you could say that there's a disconnect, but in a way it's a perspective because in fairness, it is new technology, and new technology, there is often a lot of distrust and, um, it's new. There's not a lot of trust there. But the important part is for me, these technologies represent ways that we can improve the human experience. And if there is a responsible use of it, just like there's a responsible use for electricity, responsible use for mechanical energy or anything, um, it's very important that we harness it. Because like any technological advancement or thing, we naturally want to make life easier, life better. And why can't we use these technologies? Is it, of course, true that we have to use it responsibly? Would I say that will we ever rely solely on the technology? No, I don't think so long as people can live and breathe and think on their own, will we ever not want to, use and experience, let's say, real life. So what I'm trying to say is, I don't think it's good to present them as enemies, like that technology is a takeover. But again, to remember that many new technologies are presented like that they are often seen as an enemy or some kind of like scary new technology, and that we don't have to go to the extreme of saying that we'll rely only on the technology. But it's important to strike a balance and to make use of the technology that we have. Because why not make use of a good thing? So I hope that's a fair answer. Although
Thank you, sir.
it is a common thought when you talk about these technologies. It's easy to go like, wow, we're being taken over.
We have another question from Pau. Renee, would you like to read it?
All right. Okay. So Pao says, seeing the benefits of smart home products, although rely heavily on the internet, should we start investing in creating and building a smart home?
Okay. I think the fair question there is, I don't know. There's no solid answer because like any technology, it depends on what. Are they foolproof? No. Um, would some people trust the technology with their lives? Yes. Would others not? Yeah. For me personally, I don't think I would trust yet everything to a smart home. But the point is there is, if it's something you want to explore and it's something you want to try, and if you want to see how the technology works, why not? Um, there are a lot of new technologies that can make life easier or even safer. The example would be simple things like smart plugs that can monitor electricity use. Um, they may not have to be so drastic. And sorry, I think we're going on a tangent. The main point is you can choose to if you want to adopt the technology. It's still developing. There are a lot of new technologies that are on its way. Um, and at the moment, it's still being developed. So no technology is perfect. You could choose to invest in technology heavy homes because honestly, I feel like if you don't, well, that's the future. People will be using this technology in the future and it'll only continue to develop more and more. So would it be worth it? Sure. But the question is always, you don't need to if you don't plan to use technology. But it is definitely going to be a part of life, whether we like it or not.
Okay. Thank you, sir. Um, there are no questions. There are no. Oh, wait. There are more. Sorry, in the direct message from Raven. She asked, while use of technology helps us relief of physically tasking jobs, what can you think would be a solution to the jobs lost due to these advancements?
So I think that kind of question happens a lot, especially when we talk about digital fabrication. And the answer there is, in some ways, okay, I'll use the analogy before. These technologies seek to shift humans as operators of problems to problem solvers. What this means is, usually when we talk about jobs lost or opportunities, they're because these kinds of work are either repetitive or something that can be performed better or more efficiently by a computer. But that doesn't say that there isn't opportunities for humans out there. Um, Whether we like it or not, humans have to learn and improve and adapt. If certain jobs are lost, which does happen, um, that is not to say that there's nothing they can do. Uh, Usually it's easier if you work in specifics, because normally when I deal with this context, for example, we're talking about, let's say, industries like sculptors. Usually the argument is that if you see it as perspective of as jobs being lost due to these technologies, it's important to also realize where can humans evolve and elevate their tasks. Meaning, rather than being people who operate simple tasks, can they do tasks that are more problem solving? Rather than, um, yeah, it's kind of difficult because I don't know what the context of jobs being lost are. But in the usual context we get is like carpenters. If a CNC machine replaces like 10 carpenters, what are they going to do? Well, the answer there is the CNC machine also allows 10 carpenters to do more. It depends on what the center is, because again, these technologies are tools to serve humans. If the tools appear to replace humans, then that means that's an improper implementation of the technology. Meaning either the humans that are being replaced aren't properly given the right support to either find new work or new kinds of applications of their skill, or technology isn't being used in a way that's efficient. Um, in the context of, for example, carpenters and milling machines, um, they allow them to leverage more working power, meaning they can make more furniture. But the workers will always need to be there to create the designs because a computer can't do that. A computer can't think like a human. It cannot solve problems the same way a human can, no matter how advanced the technology is so far. um, there will always be a place for humans in these kinds of environments, especially in a digital age. In fact, the more we look at these digital environments, the more we see where humans fit. They will be evolving their task too. So, sorry, that's my main answer. Just as labor is evolving, like machines evolve to do more complex works, humans at the same time must also evolve. We cannot be content doing simple tasks, but we must also evolve to solve higher level tasks. If the expectation is that we stick to a single job and we don't evolve and improve or innovate from that, then naturally, whether you like it or not, time will put you out of date. You will get replaced one way or another. And it's happened many times before in many industries. But there will always be places where humans are important and they are essential in the backbone of this kind of structure. So as robots evolve, so must humans. That's why it's important that we do these things to stay aware and stay conscious of these technology, of these advancements, so we can see exactly why we need to evolve, exactly why we need to continually think, innovate, create. So that's what I would say. It pushes both ways. Machines evolve, humans have to evolve too. I'm sorry, it sounds so harsh. I sound like some kind of like a bad guy in a movie. Humans must evolve, but it kind of works that way, whether we like it or not, change will happen. And yeah, but I get the sentiment, and it's not a solid answer for me either. It is something we need to explore. And I think it's just responsible application of technology. Yeah.
Thank you, Sir Gideon. That was a very insightful answer. So, everyone, that concludes our Q&A. So, thank you all so much for participating.
Thank you again to Sir Gideon, Accelerating Makers HIFI team, and my partner, Renee, for making this social innovation talk possible. And of course, we would like to thank you all, our dear audience, for joining us this afternoon and the past SIT Talks. Once again, this has been Pat Kabansay.
And Renee Posadas, your host for this afternoon. Thank you very much, and we hope to see you again in our future events.
Thank you, everyone.
Thank you
Have
everyone
a
for
great
attending.
evening.